Hello, everyone, and welcome to our session, Behind the Scenes Working to Decarbonize Digital Services at Scale. My name is Chris Talbott. I work in the product marketing organization here at Google Cloud, and I lead some of our sustainability engagements with our customers. Over the past couple of years, I've actually had the opportunity to meet with over 100 customers to talk to them about how cloud technology could potentially help them make their business more sustainable. I get to work with a lot of amazing people across Google, including Kendall. Kendall, you want to introduce yourself?
Yeah. Hi, I'm Kendal Smith, Program Manager for Carbon Intelligent Computing. I also get to help Google engineers build products most efficiently and most sustainably.
So, folks like Kendall and I, and many others across Google Cloud, we're working to build sustainability into everything that we do, which means we're considering the carbon emissions and the carbon impact of the products and solutions that we build. The digital services that organizations throughout the globe are either building or consuming from vendors like us require an enormous amount of electricity, the production of which, of course, emits carbon. So, we as developers or IT leaders or business leaders with technology projects, we have this amazing opportunity to actually reduce this digital carbon footprint. And it's a very large opportunity. With the world increasingly going digital, the potential for reducing carbon emissions is huge, according to IDC's recent report. Over 1 billion metric tons of carbon emissions, the equivalent emissions of the electricity to power over 120,000 homes for an entire year. Now, in this IDC report, one of the nuances that they importantly point out is that the opportunity in front of us when it comes to sustainable IT is to actually even go beyond offsets or compensating for the carbon that we emit towards becoming truly carbon free. And so, with this positive impact in mind, the question for all of us is how can we more quickly achieve that goal of full decarbonization of our digital services? And it's a really important goal as we face incredible challenges in the fight against climate change. So that's what we're going to talk about today in this session. We'd like to highlight a few areas where we believe we're having outsized impact on efforts to decarbonize digital services. The first of which is energy efficiency. And then we'll talk about workload flexibility that considers carbon emissions. And then project and application design, which is really about best practices for prioritizing these sustainability metrics amongst the many competing priorities that we all face. Now, one of the reasons that the IDC report predicts such a large improvement in carbon emissions via the cloud is that cloud data centers are getting pretty good at squeezing more compute power from electrical power. Throughout the past few years, the amount of computing done in data centers globally has skyrocketed, probably not surprisingly. But efficiency improvements have kept the amount of energy consumed almost flat. And these gains in energy efficiency, they've outpaced anything seen in other major sectors in the economy. So, how are we able to do that? Well, with the growth in hyperscale cloud adoption, new innovations and continuous improvements, they've helped us get more out of less. At Google, compared to 5 years ago, we actually deliver about 7 times as much computing power with the same amount of electrical power. And we've been able to do this via a number of optimizations. Since we've been operating data centers for over a decade, we've actually gotten pretty good about simply managing the supporting infrastructure, everything from controlling thermostats to airflow. But for the session today, we wanted to talk about areas that could have potential outsized impact. And machine learning is helping us achieve that. Not only helping us manage the complex systems in the data center more efficiently, like the system that controls our servers and the cooling associated with those servers, but helping us handle really energy intense computations more efficiently. New innovations with accelerators, which are basically highly efficient computer chips that we design specifically for machine learning applications, can help us get more computational cycles per the amount of electricity that we consume. And while machine learning is helping data center infrastructure become more efficient, it's also a really good candidate to take the efficiency conversation a level deeper from the entire data center to the workload level. Ultimately, we're running workloads or applications that we want to make more efficient and carbon free. So let's take a look at one of those workloads, neural network training, as sort of a case study. Google's research team recently published findings about the carbon emissions of large neural network training. Now, this is the process by which you train these models to be reused for a particular optimization or use case. And as I described, there are a seemingly innumerable number of elements in technology systems that you could potentially optimize in order to increase the efficiency of a workload like this. In our cooling system alone, there are around 20 different actions that the system can take that would affect the overall energy efficiency. So, one of the interesting findings of this research were different measures of impact for different choices that you could make when running your training model. You could choose to run the model on those custom chips like tensor processing units and have a significant impact on carbon emissions. You could also choose to run the model on hyperscale data centers versus traditional or legacy infrastructure. And finally, you could choose the location where you run the training. The last finding is really, really important. Sometimes in using digital services, we forget that they run in a place at a particular time and on an electrical grid. But many of these workloads are fungible and flexible in when they do that. So, how can we take advantage of this flexibility to reduce the carbon emissions of computing jobs? Well, let me hand it over to Kendall to talk about how we're putting that into practice here at Google.
As Chris mentioned, Google has data centers all over the world that are operating 24 hours a day. But different electrical grids have more or less carbon free energy available depending on the resources available to power that grid. Take, for example, an electrical grid that has solar power as well as wind. When the sun is shining or the wind is blowing, there's more carbon free energy available. Electrical grids are dynamic systems that are constantly changing how much carbon free energy is there. That's why our first iteration of carbon intelligent computing was to look at the times in a single data center when energy was cleanest, such as when the sun is shining or wind is blowing. Each day at every Google data center, our carbon intelligent platform compares two types of forecasts for the following day. One of the forecasts, provided by our partner Tomorrow, predicts how the average hourly carbon intensity of the local electrical grid will change over the course of that day. A complementary Google internal forecast predicts the hourly power resources that a data center needs to carry out its compute tasks over that same period. Then we use the two forecasts to optimize hour by hour guidelines to align compute tasks with times of low carbon electricity supply. In the graphic, you can see how we increase our energy consumption when these clean resources are available and decrease our energy consumption when the grid is dirtier. This first of its kind system gives us flexibility and a more proactive role in grid decarbonization. We've been able to do this without incurring new hardware costs or impacting the performance of services for our users, which we hope means that systems like this can find broad applicability for many companies and industries. A second way carbon intelligent computing can help us move towards decarbonization is by load shifting flexible compute to make smarter use of clean energy. Different electrical grids have vastly different carbon intensities around the world. For example, a megawatt used in Singapore emits more carbon than a megawatt used in Washington state in the United States. Why? Well, the electrical grid in Singapore is primarily run on natural gas, while there's plentiful hydroelectric power available in the Pacific Northwest. The amount of computing going on at any given data center varies across the world, increasing or decreasing throughout the day. Our carbon intelligent platform uses these day ahead predictions of how heavily a given grid will be relying on carbon intensive energy. We then use this forecast to shift computing across the globe, favoring locations where there's more carbon free electricity. In this graphic, you can see the carbon-free energy profile of 3 data centers. In this scenario, a compute task that would have run in data center 3, which is the dirtiest in this example, is instead moved to data center 1 that has carbon-free energy available. Now, shifting compute tasks across location is a logical progression of our first step in carbon intelligent computing. Now, Google's global carbon intelligent computing platform will increasingly reserve and use hourly compute capacity on the cleanest grids available worldwide. This system happens automatically in the background for Google's compute tasks, but we are also prioritizing internal work to reduce the carbon intensity of our services. This includes work such as instating a carbon tax for internal workloads, prioritization of efficiency programs in dirtier regions, and integrating carbon signals into our internal tools. We're trying to prioritize lower carbon compute services and put that into definitive actions and guidance. And we're hearing from our customers that they want to do the same. So Chris is going to talk about how we make sure that lower carbon services or sustainability in general are prioritized both in our organizations and in our application development.
Now, the carbon aware compute efforts that Kendall just walked us through, they're a really great example where the priority placed on a sustainability focused key performance indicator or KPI led to a unique technology innovation where we turned the ambition of Google towards proving that a carbon free future is possible into a tangible project making a meaningful impact towards decarbonization at scale. Now, we see a strong desire in the market to do something similar. In a recent survey of over 2,000 global IT leaders, the intent signals for sustainable IT efforts were really strong, with 90% of them claiming that it was a priority for their organization. The challenge is in the same survey, the group that had real targets in place today was much smaller. So we have to ask ourselves why this hesitation? And in the report, while sustainability was a must have criteria, so was data sovereignty, multi cloud capabilities, data analytics, and security, amongst many other considerations. There are many competing priorities when it comes to cloud adoption and new cloud solutions. So, one of the things that we can do to have scalable impact in our organizations is to make lower carbon impact more influential across IT projects and application planning processes. And in working with our customers, these are 5 best practices that we believe can help everyone from the organizational leaders to the project managers make a sustainable difference. So let's spend a second walking through each one of these. Making space to bring technical and sustainability teams together is critically important, not only to make sure that environmental impact considerations are included in your IT projects, but to bring engineering expertise to environmental challenges. At one of our customers, Etsy, the close collaboration between the technical and the sustainability teams actually led them to reduce their energy consumption and to power their marketplace with 100% renewable electricity. Now, deciding on a shared metric is a very practical way to include sustainability in project goals. Like you would design for availability of your application, you can also design for an environmental metric. And at Google Cloud, we like to distill IT impact down into carbon emissions. For our customers like L'Oreal, the ability to measure their cloud carbon emissions enables them to track the impact of their sustainability principles and architecture decisions downstream. Now, once you have this metric, it's important that it's accurately valued or considered in justification or ROI models. One of the challenges that the entire world faces in understanding and communicating the impact of something that feels so ethereal like carbon dioxide is having this consistent metric. So, by using the social cost of carbon factors, which prices a ton of carbon emissions at over $50, it can help you assess impact consistently with the typical cost and benefit scenarios that you'll probably undertake. So, incorporating sustainability into your planning process is a positive change regardless, but it's really important to do it early. If not, the early choices could create unsustainable technical debt for yourself. One example of this is location. With the location of workloads being such an important factor, and moving large amounts of data or applications once they've landed somewhere being actually relatively difficult to do, it's important that that consideration is taken at the beginning of the project process. So finally, consider who you are trying to influence and creating a magic moment for that audience in order to help them make the more sustainable choice. Some of the ways that we consider this at Google Cloud is to think of the developer workflow within our console and highlighting the green choices like lower carbon regions at the very moment when users are creating their resource. So, assuming you've been able to do that and you've been able to incorporate sustainability into your project strategy, there are a number of opportunities to put that into practice, into real cloud development. From designing mechanisms to automatically shut down and start up resources that are not needed, to optimizing for regions that have a lower carbon footprint, there are a number of ways to have development priorities for sustainable impact. What is critically important about many of these suggestions that you see here is that the benefits are not only carbon benefits, they often lead to efficiency, performance, and cost benefits as well. In a perfect world, the sustainability priorities at the organizational level lead to project priorities and ultimately into supporting customers with more sustainable products. That's what Salesforce has been doing with their collaboration between their IT and sustainability teams and with Google Cloud, supporting their own customers with a carbon neutral cloud every day. So that wraps up our content. And if you'd like to hear more stories like Salesforce, please check out all of the resources that we publish on our cloud sustainability blog. This week at Next, we're also going to be sharing more sustainability content. We're hosting a session on measuring, reporting, and reducing the carbon emissions of your applications, which is a great way to put the best practices guidance that I just talked about into real practice. And we're also hosting a session about achieving system level sustainable change with AI and ML. So I'd like to thank everyone for joining us in this session. And I especially like to thank Kendall. Thanks so much for the chat.
Yeah, thanks so much for having me today, Chris.
And we're really excited to partner with all of you out there and help build a more sustainable future.